All right, in this segment, we're going to continue to talk about Le Chatelier's principle and a few other situations. So the learning objectives here, and let me switch over to the tablet. The learning objectives in this segment are to apply Le Chatelier's principle to non-participating compounds, include heats of reaction, and then look at it in some more complex situations. We're also going to understand how catalysts affect reaction equilibria, and evaluate which of a range of changes shift equilibrium forwards and backwards. So we'll add a few more concepts to Le Chatelier's principle and then put it all together. Okay, so what about non-reactive species? So here we have our good old ammonia reacting with hydrogen, nitrogen reacting with hydrogen to produce ammonia. And the system reaches equilibrium in a rigid 20-liter vessel, and I introduce 20 moles of helium gas into the reaction vessel at constant T. You can imagine there is no reaction that happens between helium and any of those compounds. What happens? So think about this. Here's three possibilities. The equilibrium shifts to the right because there's more gas, so the total pressure increases, disfavoring the side with more gases in reactants versus products. B, no. The equilibrium shifts to the left because all the gases have become more diluted, meaning the concentrations in the denominator get lower. Or C, nothing much happens. The molar concentrations of the substances involved in the reaction have not changed. So think about that for a second. Pause. Okay, we're back. Let's talk through it. So the answer ends up being C. Nothing much happens. The molar concentrations of the substances involved in the reaction have not changed. If you think of it in terms of a Kc, the concentration of nitrogen, hydrogen, and ammonia are completely unchanged by the introduction of helium into the vessel. So Kc, yeah, doesn't change when the other compounds are added. Kp, here's an important thing. Although the total pressure changes when the moles of gases appear, the partial pressures do not. It's the partial pressures that occur in the expression for Kp. So the partial pressure of nitrogen is not changed by the introduction of helium. The partial pressure doesn't change, so Kp doesn't change, so the reaction equilibrium remains the same. So introducing some other species that doesn't react does not change the reaction equilibrium.